So now that we've talked a bit about Spring and kind of the components that it provides that you'll end up interacting with, and some of the components it uses internally that you'll also interact with, but somewhat indirectly, let's talk about SpringWebMVC. And this is what you're actually going to use in programming assignment number 2. And this is going to be the part here on the right, which is the so-called servlet stack. And that is based on the servlet API, as you can see here. And it uses a synchronous blocking I/O architecture with one request per thread as the concurrency model. So we'll talk about this, how SpringWebMVC works. We're first going to start by talking about its concurrency model, and then we're going to talk about its communication model. How does it send information back and forth? And the nice part about this is most of this stuff is hidden from you because using the convention over configuration pattern, we're going to be able to eliminate a lot of the annoying distractions and the things that you would otherwise have to wrestle with at a low level, and we'll push down those accidental complexities and focus on the business logic that you're doing. So we're first going to start by talking about SpringWebMVC concurrency. Under the hood, this is built on top of the servlet API, and it uses a synchronous I/O architecture. I'll explain what that means more in a second, with one thread per request, or a request per thread, or a thread per request, or however you want to read it. What that means is that each request from a client is handled on the server by a thread that blocks until it's able to fully process the request. So when a request comes in, then it will go ahead and be handled by a thread, and we'll talk where that thread comes from. So the client sends a request to the server. There's a thread over there that takes the request, does its thing, sends a result back to the client. Client can then send another request. Either the same thread or a different thread will handle that request, send the result back to the client. So you'll notice that the interactions here are so-called synchronous, or blocking. The client blocks, and the server thread doesn't return until the computation is done. So here's a very simple example with a little fun animation. You might have a client application that's going to populate some kind of an interface where you want to know what flights are available to go from Nashville to Oakland or wherever you're going to go to. And it will then send a request over to the server saying, find me some flights. And then it'll come back with a list of flights. You might say, I don't want to go there. I want to find a different set of flights, make another request. They'll, again, be synchronous blocking, get the results back. And so what happens here is that the calls from the client block, and the server's processing also blocks, in the sense that it doesn't, this thread will continue doing something until it returns the result back to the client. This is typically what's called request response, synchronous request response communication, and concurrency for that matter. Blocking calls are a natural form of something called back pressure that forces the client to wait, or the calling client thread to wait, until it gets a result. So the client can't sit there and make a lot of requests in one thread easily. Instead, it has to make a request, block, get a result back, do the next thing, make a request, block, get the result back, do the next thing. Now, if you want to have things go concurrently on the client, you'd have to spawn more than one thread, and then those could run concurrently. But that opens up a whole new can of worms, because now you've got to coordinate all those threads. One of the nice things about the synchronous request response style model is there's no need, or very little need, for end-to-end rate control, because you're not able to send requests faster than the server can respond, because you really can't send another request easily without waiting until the result comes back from the server. So as a result, we don't have to worry about end-to-end rate control. That will be different when we talk about the asynchronous model later in the course. However, the downside with the synchronous I/O model we just talked about is there may be many threads needed to handle bursty clients. So the server may have to have a big pool of threads. So that's one problem. And if the client wants to have multiple things going on at the same time to get better throughput, it also has to spawn many threads. And both of those things can become an issue, because at least in modern, contemporary Java, we don't have lightweight threads. So having a million threads is pretty much out of the question. You're going to be in big trouble. And you could very well have lots and lots of requests. Even having more than 100 or so threads are probably starting to get into the direction where you're having problems with with memory capacity and processing and so on. That may change with Project Loom, but right now that's the constraint we deal with. So having lots of threads that sit in a pool is not necessarily the most effective way of programming high-performance web systems. Let's now talk about the other piece of the puzzle, which is web communications using SpringWebMVC. So the way it works under the hood, from what you see as a programmer, well, not under the hood, the above the hood, is that communication takes place using common Java types, such as Java collections, and other types like integers and strings and non-collection types. And so these are some of the collections you're familiar with in Java. The ones that are most important here are things like list and set and map and so on. And the communication uses things like we're seeing here. So here's an example where we might go to our server, and we might say, tell me all the departure dates going from this airport, the departure airport, to this arrival airport. And what you get back, as you can see here, is a list of date objects. So that's just showing you can write code that looks like conventional Java, and under the hood, the controller and the servlet engine and so on from SpringWebMVC will do all the work to make things look like lists from the programming point of view. I'll talk later about what some of these annotations mean, like get mapping and request param and so on and so forth. The WebMVC endpoints, when you send collections, send and return them in one fell swoop. So what does that mean? That means that if you go out and say, give me all the lists of airports or the list of departure dates or whatnot, then the response does not come back to the client until the entire list has been assembled in server memory, and then it's sent back in one fell swoop as one big bulk chunk. Well, you might think, gee, how else are you going to do it? Well, it turns out that there's other ways to do it that are perhaps more effective and more scalable in some circumstances. Why this is problematic is because client latency may suffer because you have to wait for the server to assemble the entire list. And if it takes a while to assemble the list, you don't get any results until everything is ready to be sent back. So the client may be less responsive. And the other problem, which may or may not be an issue, is you also have to use all the memory on the server to accumulate everything into one giant list. You have to send that as a giant buffer back across the network, and then the client has to handle everything as a giant list. So you may end up using a lot more resources and a lot more overhead to make all this stuff work than you necessarily need to do. Now, the way this is addressed, as we will see later in the course after we've talked about reactive programming, is by doing things asynchronously and being able to stream the results back as they are produced. So you don't have to wait for everything to come back in one big giant blob, one big aggregate chunk, one fell swoop, as I called it, but instead you can get incremental results that come back from the server back to the client. So we'll talk more about that. I'm just giving you, this is actually cool because you'll learn the way that people have historically done things, which works. It's used all over the place. And then we're going to see how to do it more effectively with other technology that are still part of the Spring family of platforms and frameworks. So that's the end of our overview of SpringWebMVC. You now know conceptually enough to do the next programming assignment, but we have to start giving more examples of how to actually do this stuff in practice, which is what we will do next.